All right, so we're going to take a look at the 5.1 homework solutions. For these limits, again, the first thing you're always going to want to do is substitute in to see what you get. If you get something other than 0 in the denominator, you're done. If you get 0 over 0, there's more steps to go, and we'll know that that limit exists, but the point does not. So number 1, I substituted in 3, ended up with 0 over 0. So I factored my numerator and denominator. Once you have 0 over 0, if you have two polynomials, something should always cancel. If something doesn't cancel, it means either your first step was wrong or your factoring was wrong. Once I've canceled, I substitute 3 back in, and I get 7 over 6. And again, since I got 0 over 0, I know my limit exists. The point does not. And that's an important idea that you want to keep in the back of your mind at all times. Number 3 is a good example that we always substitute in prior to looking at what could happen if we factor, because I get something other than 0 in the denominator, and 0 divided by 5 gets me 0, so I'm done with this problem. And since I didn't get 0 in the denominator, I know my limit exists and my point exists. Number 5, I substitute -2 into all my x values. I get 0 over 0. I factor my numerator and denominator. Again, if you've gotten 0 over 0, something will always cancel out. I reapply my limit, and I get 2. And again, because I got 0 over 0, that tells me the limit will exist. The point will not. Number 7, substitute in 1, get 0 over 0. Again, I factor using my difference of cubes, factor my denominator. Once you've had 0 over 0, something should cancel, and I get 3/5 as my limit. Number 13 is a little bit different. I substitute in and I get 0 over 0. While we do still expect something to cancel out, I know that I've got to multiply by my conjugate, so I'm going to use the opposite sign that's in between the two radicals. In the original, I see a negative, so I'm going to use a positive, and then I multiply. Again, this creates a unique difference of squares in the numerator, so my square roots are gone. Notice that I'm subtracting, because we know the difference of squares leads to a squared minus b squared. Once I get to my simplified step, that's when I'm going to see something cancel. So my x is canceled. Be careful not to lose the -1 in the numerator. Substitute in 0 again, and root 5 plus root 5 is going to get me 2 root 5 in my denominator. And again, since I had 0 over 0, I know my limit will exist. The point will not. Number 16, very similar. I substitute in the 9. I end up with 0 over 0. So again, I multiply by the conjugate of where I see the radical. Leads to a unique difference of squares. So I've got my 3 squared minus root x squared. My 9 minus x and my x minus 9 will cancel, leaving me with -1. So I substitute in 9 again and end up with -108. Number 18, very similar. Again, I substitute in. I get 0 over 0. Multiply by my conjugate of where I see the square root. Notice again, I'm not changing what's in the square root. Leads me to having root x minus 3 squared minus 1 squared. From there, I combine my like terms. I see my x minus 4's cancel. Substitute 4 in again, and find my limit. Now, multiple choice number 1, the fact that it has an a in it, a is just a number. If you wanted, you could replace the a with any value you choose, but if you can recognize that it just represents a number, you can keep working with it. Again, I substitute in what my limit is approaching. I get 0 over 0. Factor my numerator. My denominator is another difference of squares, but I can keep factoring it. I cancel my x plus a, my x minus a. Reapply my limit, and get 1 over 2a squared. And again, this idea that I got 0 over 0 means my limit will exist, but the point will not, continues. Multiple choice number 3, set up a little uniquely with the fraction and a fraction, just means I'm going to have to clear fractions. Substitute in and get 0 over 0. So to get rid of this fraction within the fraction, I'm going to multiply by the denominator I see here of x minus 1. what that's going to do is cancel out the fraction within the fraction. So when I distribute x minus 1 to 1 over x minus 1, I get 1. When I distribute x minus 1 to 1, I get x minus 1. And then, of course, x times x minus 1 gets me x times x minus 1. You'll notice I'm not multiplying it out because I know in these problems my goal is to be able to factor and cancel, so I haven't multiplied anything out. Combine my like terms, gets me x over x times x minus 1. The x's cancel. I'm left with 1 over x minus 1, substitute in 0, and find my limit. All right, this is the beginning of our introduction to calculus. Using the limits, we'll be able to find what we call a derivative, and that's what we're going to look at in the next class.